Hi, students. In this lecture class, we are going to see the numericals about, about generation of switching equations, and also we are going to see the Karnaugh maps. Okay. In last class, I think discussed about how to write the problem statement and how to generate the truth table. Okay. And also, we have seen how to write the switching equations from the truth table. And with that discussion, say these are the points. Say canonical mean term expression. How we are going to write? Here we are using SOP. SOP means sum of product. Okay. Now the SOPs are written for output is one, and this canonical mean term it is to be denoted as sigma symbol. Okay. Now look at this example. See, all the problems what here it is to be solved, those problems are chosen from your world question paper. Okay, so these are the very important examples. See here, what is asked? Write canonical min-term expression for the function shown in the figure. So here the truth table is given. For this truth table, you need to write the canonical min-term expression. Canonical min-term expression means you need to consider logical one output, okay, among the truth table given. And for that, you need to write the equation. Okay, here you have two logical one outputs, right? Now for that, you consider the product term. So how many product terms you will get here? Two product terms. Okay. Now you add these two product terms, so then it will become the canonical min term expression. Okay. How it is to be written? Say the way of writing canonical min term expression is first you need to mention the function. Okay. Now the variable here it is to be given x comma y. See here, please follow the sequence. X is MSB. MSB means most significant bit here. Y is least significant bit. So while writing sequence inside the function, first variable you need to write the MSB. Okay, say x comma y here it is to be written. So don't mix up the sequence. Don't write y at the beginning. If you write y here, the entire the meaning of the equation is going to change. Okay, please remember this. Okay, now for the first output, the input combinations are 0 0, right? So the equation will be x complement into y complement. This is the first product term. Okay. And this is to be added or sum, or it is to be logically ORed with second term. Second term combinations are 0 1. So it is x complement into y. Similarly, look at the second example. Here we have three input variable output table, right? So eight combinations you will get. Now, since here canonical min term it is asked, so you need to consider logical one outputs. It is a logical one outputs here, one outputs here. We have five combinations, right? One, two, three, four, five. Okay. You look at the input combinations for this and write the product term for each combinations, and finally you sum all the combinations. So then you'll get this canonical min term expression. Understood? Yeah. You look at just the reverse way manner. It is to be asked here question. What is asked? Write the truth table for the following function. Here function is given, so you need to write the truth table. Okay, what function here it is to be given? F a comma b comma c. So a b c are the inputs. A is the MSB, C is the LSB. Okay, equation is a complement b, c complement plus a b complement c plus abc. So better you convert the given equations in a binary form. Okay, this is for your reference. 0 1 0 1 0 1 1 1 1. Next you write the truth table. So you can write the truth table, right? Okay, eight input combinations you write. Okay, now before writing output, Now, the equation, the product terms in the equation, okay, this will going to represent what? The logical one output of the truth table. So, the combinations, input combinations of within the equation, for that you write logical one outputs in the truth table. Then, the output for the remaining combination, that is 0, right? You fill up 0 for the remaining combinations. With that, the truth table is completed. Understood? Okay. We look at here. What is asked? Write the canonical minterm expression in sigma notation for the function represented in the below figure below. So canonical minterm here it is asked, and also it is asked to write with the sigma notations. Okay. Yes. Canonical minterm form you can write for logical one output, that you know, right? Okay. See, for your simplification purpose, one more column it is here. It is added. That is to write the terms. Okay. So you write the equations here. You know how to write. Next, write the sigma notation. But sigma notation of this. Sigma notation of this means what? Decimal equivalent of this binary combination. Okay. The binary combination of this x complement y into z complement is 0, 1, 0, right? Okay. Okay. That is the decimal equivalent of this is 2, right? Okay, you write 2. Next, for the second term, that is 3. Next, for the third term here it is, right? For that it is 5. So sigma notation is 2, 3, 5. I hope you understood that. Huh? Okay, next. Here what is asked to write the truth table for the given function. Say in a given function, what is given? Sigma notation. Sigma notation it is to be given. So it is very easy. Sigma notation, the decimal equivalent of the binary combination, right? Okay, for these combinations, your output is logical. For the rest of the combination, the output is 0. That's it. Very simple, isn't it? The next one is canonical max term expression. This is quite opposite to SOPs. Okay. Say how you are going to write this. See POS we write for output 0 and it is to be denoted by 5. Say while expressing canonical max form, look out for the rows for which the function evaluates to 0. This is very important point you need to keep in your mind. Okay. Okay, look at it. What is asked here? Write the canonical max term expression for the function shown below. Say this is the truth table. Say in truth table they never give the terms. Okay, the terms you need to write. So now simplification. What here it is to be done? All the terms it is to be written for all the combinations. Okay. Since it is POS, each terms are what? Sum of the literals. Okay, sum of the literals, and also for logical 0 you need to consider as it is variable. For logical 1 you need to consider its complement. That is the difference. Okay. Now how you are going to write the equation? So for writing equation you need to consider logical 0 output among the truth table. So how many zeros we have at output side? 1, 2, 3, 4, 5. So 5 terms you will get it in the equation. See, in this way, the canonical max term it is to be done. Now what is the second example here it is given? Express the function shown below in canonical max term. Similar thing, truth table it is given. So you need to convert that one into canonical max form. Okay. Now, pi notation. Simplify writing in the canonical max form. So pi notation you need to write. Pi notations, same thing. Logical 0 output only you need to consider. This is also POS, canonical POS expression only. After writing that, next you need to convert that from binary equivalent to decimal equivalent. Okay, that is the difference. Okay. For the first 0, what is the decimal equivalent of this combination? Is 1, right? Only thing is you need to use the symbol pi of 1. Okay, for this it is 5. Okay, next for this it is to be 7. This is pi notation. Okay. It's in similar manner. See here, the pi notation it is to be given of max term. So you need to write the truth table. Okay, here the input variables are not mentioned. How are you going to consider input variables, number of input variables? See, the maximum decimal notation is 15, right? So with that, you're going to understand. You need to consider four input variables. Okay, with four input variables only, you can cover this, right? 15 decimal equivalent of the input combination, isn't it? Okay, you can consider five variables, but if you increase the number of variables, what will happen? The size of the truth table will going to increase. It is unnecessary work, right? So if you restrict for 4, so that covers all the decimal equivalent which is to be given with the pi notation, right? 4 input variables are enough. Okay. Now write the truth table with 4 input variables. Okay. So these type of problems you can expect in question papers. Okay. So what is asked here? Express the following in both canonical max term and min term forms in decimal notations. So here SOP is given f of x complement y plus y into z. Now while seeing this SOP, so you will come to know that here the number of input variables are 3, right? X, Y, Z. If you look at each term, so according to the ru- rule of SOP, each term has to consist all the input variables. But in here, each term, one of the variables is missing. So first you need to simplify this. You need to convert these terms in such a way that each term should consist all the input variables. You know how to convert this, right? You first take the first term x complement y. Here the missing term is z, right? Okay, how will you going to convert that? So you need to multiply z plus z complement with this term. You simplify. Similarly, you simplify yz. So you will get yeah this term, right? Okay, now among these two terms, say x complement yz are common term, right? So not common, it is repeated. So you consider any one, okay, to write the final expression. F is equal to 6. This is the final expression. Now what is asked here to write the decimal notations, right, of max and min term. So here you consider SOP. So first you will going to write min terms, decimal equivalent min terms. Okay. Say you write the min terms of this. Before writing midterms, you need to write the binary equivalent of these terms. 0, 1, 1, 0, 1, 0, 1, 1. 0, 1, 0 means 3, 0, 1, 0 means 2, 1, 1, 1 means 7. Okay. Now write the sigma notations. So you need to write from smallest number, isn't it? In ascending order, you need to write 2, 3, 7. Now what is asked here? Also here it is asked to write the max term. So if you know the min terms, then you can directly write the max term of this function, right? Okay. 2, 3, 7 are the min terms. So the remaining combinations are max terms. So write here. Pi of 0, 1, 4, 5, 6. I hope you understood this problem. Similar type problem here it is asked. Okay, here the POS equation is given. Okay, so first you need to simplify this. You look at each term. While looking the equation, here also there will be three inputs, isn't it? But each term it consists only two input variables. So first you need to convert this one into yeah, you need to rearrange the terms. How you going to rearrange the terms in POS? In POS, what you are going to do? You will going to multiply. You will going to add the missing variable. How you going to add the missing variables? product of what? Variable and its complement. So in Boolean algebra, you know that C into C complement. What is that? It is 0, right? If you add 0 with any term, it does not change the value of that, right? So you can add this. Now simplify this. So you'll get the terms here. So with the terms which is obtained here, it consists all the input variables. Similarly, you convert this b plus c complement. So you will get the two terms for this. Now among these terms, just check which are the terms which is repeating. Okay. So repeated terms you consider one. Okay. Don't uh, don't write unnecessarily the repeated terms. Okay. So total how many terms you will get here? Three terms. You write that. Now better first you convert these all the terms into binary numbers. Then convert this one into decimal. Okay, now first what we are going to write? You are going to write the decimal equivalent of max term, that is pi. Since POS equation it is given, right? Here it is given. So pi equivalent of this, it is the writing sequence is same. First you need to start from lower number 1, 4, next 5. Okay, now what are the min terms? Decimal equivalent of min terms. If 1, 4, 5 are the max terms in the truth table, then the remaining combinations are min terms. So remaining terms are 0, 2, 3, 6, and 7. I hope you understood this. These are the important type of problems. Okay. Okay. The next one is Karnaugh map. So what is Karnaugh map? So still now we see how to write the equation from the truth table, isn't it? Say in logical design, our main aim is to reduce the equation size. Say, as you reduce the equation size, say you can make circuit compact. Size of the circuit that will be going to decrease. Okay. So Karnaugh map is one of the method to reduce the size of the equation. Now, how you are going to do this? See, for that, here you will use diagrammatic representation for Boolean expression. And the representation of that, it is to be called as a map. Initially, this map method, it is to be proposed by which? This is, he is a scientist, okay. And later, the map which is proposed by which, it is to be modified by one more scientist, is Karnaugh. So the Karnaugh map, it is also called as Witch diagram. Okay, Witch diagram, and it is also called as K map. In short form, we call it as K map. Next, say how to represent Karnaugh map. See, we know that for three input variable, we get 8 row truth table, right? Similarly, 4 variable, we get 16 rows truth table, and so on. Similar to that, the Karnaugh map, you need to write for 3 variable input variable, like the Karnaugh map for that variable, 3 input variable, it consists 8 cells. Here each cell represents the output of the truth table for each combination. Understood? Similarly, for 4 input variable, we have 16 row truth table, right? So in a Karnaugh map, we get 16 cells. Okay. The each cells it represents what? Output of the truth table. Okay. Now look at the next point. See, 1 is placed in a cell corresponding to row for which the function evaluates to 1. Means how to fill up the cells of Karnaugh. The 1 you will going to write in the Karnaugh map for which cell, that cell corresponding to row, okay, at the truth table. Similarly, 0 you will going to write which evaluates 0 at the truth table. Next, in Karnaugh map, the cells are arranged. How it is to be arranged? See, it is to be arranged in such a way that those cells are physically adjacent, okay, and are logically adjacent. That means if you see the adjacent cells, okay, and if we observe the product term among the adjacent cells, those product terms are differ by only one literals. Understood? Okay. Next, types of K-map. See here we have to see this one variable, two variable, three variable, four variable, and five variable Karnaugh map. Now, according to our syllabus, here it is to be mentioned to write study three variable, four variable, and five variable. See, the drawback of Karnaugh map is as the number of variable increases, the complexity K map will going to increase. Okay. Okay. See one by one how to write one and two variable map. So one variable map relates to a function of one variable. This is a simple representation, say Karnaugh map for one variable. So for one variable we have two cells, right? So say two cells are written here. Only one variable. So the variable here it is to be taken at the upper side of the Karnaugh map. P. And input combinations are 0, 1. For that, what is the output? Function it is to be given as f of a is equal to a complement. So complement of a. If 0 is input, then output is 1. If 1 is input, then output is 0. So fill up the output from the truth table within the Karnaugh. I hope you understood. Okay. Now these are the cell numbers. Okay. The cell numbers it is to be written based on the input combinations. Okay. For 0 input, it is 0 cell number. Okay. For 1 input, this is 1 cell. Okay. Cell number 1. Say the marking of variable input combination cell numbers are mandatory. Okay. Then writing the output within the cell that you know how to write. That is also mandatory. Okay. This is a simple one variable Karnaugh. Next, we'll see two variable Karnaugh. In two variable, we have two variables. In two variables, we have four combinations, right? Okay, so we'll get four cell Karnaugh. See how the four cells are arranged here. The four cells are arranged in such a way that it is to be arranged as two row and two column. Okay, why two row and two column? Why? Because here we have two input variables, right? So among two input variables, so you need to consider one of the variable along with the left side and one of the variable along with the upper side of the Karnaugh. So here A and B, right? A is MSB, B is LSB. So usually we take MSB along with the left portion of the Karnaugh map and LSB along with the top portion of the Karnaugh map. Okay, now you write the input combinations. So input combinations for A it is 0 and 1. Similarly for B is 0 and 1. Okay. Now based on that, first you mark the cell numbers. Okay. Say first cell. This is first cell, right? So cell number for that is 0. Why 0? Because the input combination for this cell is 0, 0, right? So you need to consider together two variables together, right? AB, because function is AB, right? So 0, 0. So this is 0th cell number. Okay, now this is one cell, cell number 1. This is cell number 2. This is cell number 3, isn't it? Because the input combination for this is 1, 1. So it is 3. Okay, now fill up the outputs. See, for cell number 0 it is 0. For cell number 1 it is 1. For cell number 2 it is 1. For cell number 3 it is 0. This is the Karnaugh map representation for two variables. In three variable maps. Say in three variable maps, say you will get 8 rows in truth table. So 8 cells you will get in the Karnaugh map representation. Say in three variable representation of maps, you just remember the point that usually Karnaugh map we will going to plot on a cylinder. Because of that, each and every sides of the Karnaugh map which are physically related means are logically related. Means left portion of the Karnaugh map it is to be related. You can relate with it is to be related with the right side. Similarly, upper portion of the Karnaugh map it is to be related with the lower portion. Means which are logically adjacent or which are physically adjacent. Understood? Okay. Okay. With the example, you are going to see. Say very simple example. It is to be given three variable in your function. Okay. And for that, you need to write Karnaugh map. First, you write the truth table. Okay. Now, from the truth table, try to construct a Karnaugh map. In three variable, say normally we take MSB along with the left portion, right? Same here A is MSB, C is LSB, right? Okay. You take A along with the left portion and the remaining two variable B and C you take along with the upper portion. Understood? Okay. Now make the Karnaugh map. So with that you will get 4 rows and 2 column Karnaugh. Now look at the input combinations at the upper portion. 0 0 at first, next 0 1, next 1 1, next 1 0. See these combinations. This is a standard format. Okay, standard format. This is in standard format. So you need to follow this sequence. Don't mix up the sequence here. Okay, 0 0 0 1 1 1 1 0. Now on the left portion, no confusion. One variable, so two possible inputs 0 1. Okay, now for all the combinations, first you mark the cell numbers. Okay, you know how to write the cell numbers 0 1 0 1 3 2 4 5 7 6. These cell numbers are written based on the input combinations. Okay, next mark the outputs within the Karnaugh. Okay. From the truth table, you mark all the outputs within the Karnaugh map. Say after mapping this, this is what the actual representation of Karnaugh map. Usually we do these maps on cylinder. Because of that, see the edges of the Karnaugh map, WX, it is to be logical adjacent to YZ. Similarly, WY is logical adjacent to XZ. So you can relate. Okay. Cell number 4 with 6, cell number 2 with 2. Similarly, cell number 2 with 4, cell number 1 with 5, cell number 3 with 7, cell number 2 with 6. Understood? Okay, next 4 variable map. In 4 variable map, we have 4 input variables, right? A, B, C, D. So, first 2 variable we take along with the left hand side and the next last 2 variable we take along with the upper side. So in 4 variable input we know that 16 rows we will get at the truth table in the truth table, right? So in Karnaugh map we will get 16 cells. Okay. Now with this variable arrangement in Karnaugh map we will get 4 rows and 4 columns. Okay. Now for the given function, see the truth table here it is written. Okay. See this is the Karnaugh map representation. Okay. See, AB is to be taken along with the left portion, CD is taken along with the upper portion. Now, the input combination for these variables, say 0, 0, 0, 1, 1, 1, 1, 0. I told in previous slides, say these are the standard form to write the input combination. Okay. The similar format you need to follow at the left portion 0, 0, 0, 1, 1, 1, 1, 0. Understood? Okay. Next, you write the cell numbers for each cells. Okay, these cell numbers is to be written based on the input combinations. Okay, next fill up the outputs within the each cells. In this way, Karnaugh map it is to be represented for 4 variable. I hope you understood, isn't it? Okay. Now here are some of the examples uh, which shows how to write the Karnaugh map. Okay. So here the Karnaugh map it is to be asked to write for this function. Say this is 3 variable, right? So you know how to write the 3 variable Karnaugh map. So you have 4 columns and 2 rows at Karnaugh map, right? Yes. Say look at the second equation. See in second equation here there is twist in the equation. What twist here it is given? Say the equation it is mentioned here, it is incomplete equation. Why? Because here we have 3 input variables, isn't it? And the equation which is given here is SOP. With that you can understand it. So SOP which is given here is incomplete. So you need to complete that equation first. Okay, you know how to complete that. So you will get a finalized equation. Now on for that finalized equation, you need to write the karma. Understood? So look at here, the similar type problem here is given. Okay, here also with the Karnaugh map, uh, they will they can ask to write SOP equation and to write the sigma notation. And from this, they may ask to write the POS. You know how to write the POS from the SOP, isn't it? From sigma notation. Okay, for that here the pi notation it is also is to be written. Okay. Canonical SOP and this is canonical POS. Okay. With that, I'm going to finish here itself. Okay. This is the Karnaugh map representation. Okay. Thank you for watching.